So we start out with something that you really don't have probably a good indication of how to solve. I'll tell you why we do that. The height of a basketball shot is given by this equation, minus 7t squared plus 16t plus 6. If you've got your book, you can follow along with this. T is the time in seconds after I release the ball, and h is the height of the ball on its way to the basket, okay? Now, the reason I bring up this question is this is where we are going to end up around Christmas time. We're going to end up working problems like this. But I made the question a little bit easier today because I made a multiple choice, okay? Now, what is the initial height of the basketball? Anybody know what the initial height of the basketball is? Let me scroll down just a little bit. What? Yeah, 6. Why do you get 6? Yeah, so there's 6 at the end of this equation. But think about it. Okay, if I've got the basketball in my hand, how much time has elapsed? 0. So it is 0 seconds after the ball has, if the ball is in my hand, it's been in the air for 0 seconds. What happens when you plug in a 0 for this? 0 plus 0 plus what? This is 0, this is 0, this is 6. So that initial height of that basketball is 6 feet, okay? So again, you'll figure this out. You know, that one's pretty simple to figure out. What is the approximate maximum height of the basketball? Okay, how high is the basket right here? I told you how high that was. What? 10 feet. Okay. What kind of path does the ball usually take? Yeah, it's parabolic. It usually goes higher and then it goes in the basket. Okay. So, which of these is the maximum height? Do you think 6 feet would work? No, 10 feet. Which of the other looks more realistic? Yeah, it would look goofy. Mathematically, it's possible to shoot that ball 50 feet in the air, but that would look pretty goofy to do that. Most of them don't happen. So you could figure that out, 15 feet. But by the end of the semester, I won't have to give it to you multiple choice. You'll be able to tell me it was 15.4 feet. You'll be able to figure that out exactly by what we do with parabolas and quadratics. How much time elapses from the moment the shot is taken until it goes in the basket? What do you think? Yeah. And this is just from, you've watched basketball games, you know, half a second, wow, that's just not going to happen. 5 seconds is an eternity with the basketball being there, 10 seconds. So the most natural is 2. But by the end of the semester, you'll tell me it was 2.2 or 2.3. You'll be able to figure that out exactly. So those are 3 mathematical questions. The next one, by the end of the semester, I don't know that there's any math for this one. What do you think the shooter should wear? There we go. Somebody thinks they must think it's extra credit if they give me the Woodward regulation Sperry's. But anyway, this question has no correct answer. It's just there for humor. So anyway, I showed this problem at the beginning of the semester because this is where we're headed. So it'll be November, December before we get really deep into this problem. By the time we get there, you'll have more skills about how to answer that exactly. So let's take a look into the topic for today, which are matrices. Okay. So if we look at, this is called a system of equations. How many equations? 3. How many variables? 3. So you've got 3 variables, 3 equations. So we'll say it's a system of 3 unknowns, 3 variables. So you could solve this for x, y, and z using methods that you did in Algebra 1. But what we're after is there's a way to solve this by just extracting the numbers. Okay, a matrix is just a rectangular array of numbers. We're not quite there yet. I can't right today give you how to jump from here to here and solve it. We've got to do some work with matrices to get there. But that's the point of matrices, is you can just extract the numbers and then work with the numbers and solve equations that way. So we'll do some that are this big, or 2 by 2 matrices. Well, you know what that means in a moment. But computers will solve these with thousands of rows. But this is just an abstraction way of dealing with solving equations. So let's deal with a few definitions. First of all, a matrix is just a rectangular array of numbers. And we define matrices by rows and columns. It's just like Excel spreadsheets. The rows are, how do you find the rows? They are what? what component? Horizontal, vertical. Yeah, row is horizontal, a column is vertical, okay? So the horizontal component of a matrix is called the row. The vertical component is called the column, okay? So this matrix has 2 rows and 2 columns. Now, the dimensions of a matrix are what we get from the number of rows and columns. So look at this matrix A. How many rows does this one have? It has 3 rows. How many columns? 2. So we will say that this is a 3 by 2 matrix, okay? So it's not 3 times 2, but we just say a 3 by 2. So 3 by 2 matrix, that's what it means. It has 3 rows, 2 columns. The first number always represents the rows. Second numbers always represent the columns. How many elements are in a 3 by 2 matrix? 6, okay? You can count them up. 1, 2, 3, 4, 5, 6, or 3 times 2 is equal to 6. So it tells me there's 6 elements in that matrix. Now, another notation that we use is we use these subscripts. A11, A12, A21, 22. What do you think that means? Row and column, okay? Everything, this is the first row and the first column. So this element A11 is in the first row and first column. So it's in the first row and the first column, okay? This element is in what row? Yeah, third row and the second column, okay? So that's just a notation that we use, okay? So if you see something like the element A22, that's the element in the second row and second column. Now, we're not going to use this much today, but tomorrow, or no, I see you Friday. When I see you on Friday and we start multiplying, this is pretty helpful in order to multiply matrices together. Okay, so that's just a way of denoting with subscripts where an element is. And now let's look at a matrix here. How many rows are in this matrix? 2. How many columns? 3. So what's the dimension of this matrix? Yeah, 2 by 3. Now remember, that's different than a 3 by 2. Okay, so a 2 by 3 has 2 rows, 3 columns. 3 by 2 would have 3 rows, 2 columns. There are some special definition matrices. A square matrix is a matrix that its dimensions are square. It's 2 by 2, it's 3 by 3, it's 4 by 4. Okay, so any matrix that has dimensions n by n is a square matrix. A row matrix only has 1 row, so its dimensions are 1 by n. So 1 by 2, 1 by 3, 1 by 4. Column matrix only has 1 what? Column. So its dimensions are something like n by 1, 2 by 1, 3 by 1, 4 by 1. Okay, so those are just some special definitions of matrices. Let's take a look and see what we can do with dimensions. So the first one is work there. I want you to tell me the dimension of the matrix. Tell me if it's a square, a row, or a column. So this one, you should all get this one right. This is a 2 by 2 matrix, which is a square matrix, okay? What is this matrix dimension? 1 by 3. What kind of matrix is that? Row, column, or square? It's a row matrix because it only has 1 row, okay? What are the dimensions of the next one? Yeah, that's a 5 by 1, and it's what kind of matrix? Column matrix. It only has 1 column. What are the dimensions of the next one? 3 by 3. So that's what kind of matrix? Yeah, that is a square matrix. What is this one? Yeah, this is a 2 by 3. Is that a square matrix? Answer is no. To be square, it'd have to be 2 by 2 or 3 by 3. So it's not a square matrix. Is it a row matrix? No, it has 2 rows. Is it a column matrix? No, it has 3. So none of the above. Okay, so it meets none of the criteria for it's not square, it's not row, it's not column. What about this one? 1 by 4, it only has one row. So this is a row matrix. What about the next one? What's the dimension of that one? 1 by 1. Okay, so this one, this is not the number 0. This is a matrix, a 1 by 1 matrix that only has one number in it, which is 0. So I know that's a lot of wording, but it's a 1 by 1. So what kind of matrix is it? It is a square matrix. Anything else? It is a row matrix. Anything else? It is a column matrix. It meets all criteria, okay? So mathematically, it's a square because it's 1 by 1. It's a row because it has one row. It's a column because it has one column. What's the next one? Yeah, 4 by 4, which is what kind of matrix? Square matrix, okay? Now, people tend to do well on this first assessment. I think I'm picking up a lot of interaction here. This is pretty straightforward, right? Okay, okay. Yeah, it should be pretty easy today. It gets a little bit more difficult tomorrow, but I think you guys can handle it. So let's talk about some operations with matrices. What do you think it means for matrices to be equal to each other? What do you think has to happen for them to be equal? Yeah, they've got to have the same, they got to be the same size, they got to have the same dimension, and then every element has to be equal, okay? So if matrices have the same dimension and every element of the matrix is equal, then these matrices are equal. What's the dimension of this one? 2 by 2. The next one is 2 by 2. So these have the same dimension, okay? There's no way a 2 by 2 matrix will ever be equal to a 2 by 3. Okay, the dimensions have to match. Now, after the dimensions match, every element has to match. So 1 has to equal 1. Well, we're in luck because what? What do you think about that? That's true, okay? X has to be equal to what? Yeah, 5. Y has to equal 7, and 4 has to equal 4, okay? These conditions are trivial. That's always going to be the case. 1 will equal 1 and 4 will equal 4. So these matrices will be equal under these two conditions, when X is 5 and Y is 7. So if matrices are equal, they're just identical. That's all that really means, okay? Now, we can add matrices or we can subtract them if the dimensions are the same, okay? So this is what kind of matrix here? This is 2 by 2. This is a 2 by 2. What do you think it means to add matrices? What do you think I would do? I'm going to get the same dimension. So I'll get the same dimension. What do you think I would do? Yeah, the 1 would be added to 1, so you add the corresponding elements. So anyway, I know it's late in the day, but I think you're getting the concept here. So when I add a 2 by 2 to a 2 by 2, I'm going to get a 2 by 2. So what has to happen? 1 gets added to 1, and that number is 2. X plus 5 is X plus 5. Y plus 7 is Y plus 7. 4 plus 4 is 8. So that's how I add two matrices together. Now, could you ever add a 3 by 2 and a 2 by 3 together? No. So they have to have the same dimensions, okay? Now, how do you think I would subtract these matrices? What would I do? Yeah, same. I mean, you do the same thing as addition. The dimensions have to match, and then instead of adding, you would subtract each element, each corresponding element, okay? So this is not algebra, this is arithmetic here. So it's a good warm-up from coming off of your summer. Now you're going to see when you have a test, you'll see several problems that look like this. I give you matrices at the top, and then I'm going to ask for stuff down the side, okay? So one of the key things you need to do is identify the size of each of these matrices to determine if the operation is defined. What is the size of matrix A? A is 2 by 2, B is what? It is 3 by 2. C is 2 by 2, and D is 3 by 2, okay? So I'm being asked to add A plus C. Can I add A and C? Yeah, they're 2 by 2 matrices, so it's 2, 4, negative 1, 7, plus negative 2, 0, 1, negative 4. So that's how I'm going to add these matrices together. What's 2 plus negative 2? 0. 4 plus 0 is 4. Negative 1 plus 1, 0. 7 plus negative 4 is 3. There we go. So that's adding those two matrices together. Am I going too slow, too fast? What do you think? Is it okay? Okay. Thank you for staying with me. I know it's late in the day, and pause it. D. So what are the dimensions of D? D was 3 by 2. B is 3 by 2. Can I subtract these two matrices? Yes. So D is x, 0, negative 1, 2, 1 pi, minus B is what? 6, 0, 1, 2, negative 1, negative 3. So when I subtract a 3 by 2 from a 3 by 2, I get a what? 3 by 2. Okay. So what is x minus 6? Yeah, that's pretty easy. What is 0 minus 0? Negative 1 minus 1. Negative 2. I heard some summer answers there. Let's get into the fall answers. Negative 1 minus 1 is negative 2. 2 minus 2, 0. 1 minus negative 1, 2. Pi minus negative 3. Yeah, pi plus 3. There you go. You got it. So again, this is not algebra. This is arithmetic. You'll probably get tired of me trying to be sarcastic about that. B plus C. What are the dimensions of B? What's C? And this is the kind of problem you will come to love. What's the answer? Yeah, undefined. Why is this a good problem to have? You are done. There are no arithmetic mistakes, okay? If you recognize up front that the thing I'm asking for you is undefined, write undefined and move on, okay? No, you're good. A plus D, what is A? The dimensions of A are what? 2 by 2, D is what? 3 by 2. Another one that I love. This is undefined, okay? The dimensions do not match, so you can't add or subtract those two matrices. Let's look at the next one here, D plus B. We just added, we subtracted D and B, so do you think we can add them? Yeah, so D plus B is just going to be, what, x0, negative 1, 2, 1 pi, plus 6, 0, 1, 2, negative 1, negative 3. When you add those together, x plus 6, 0 plus 0, negative 1 plus 1, 2 plus 2, 4. 1 plus negative 1 is 0. Pi minus 3 is pi minus 3. Okay. Okay, pretty straightforward, right? So again, today we're just getting some terminology, getting used to dimensions, used to some operations. Now, let's take a look at what it means to have what we call scalar multiplication. Scalar multiplication is just multiplying a matrix by a number. Without me telling you, what do you think it means to multiply that matrix by 2? Yeah, every number gets multiplied by 2, okay? So this is the matrix 4, 8, negative 2, 14. All I did was I distributed that 2 inside the matrix. Every number got multiplied by 2, okay? So without me even defining that, you had a sense for what that operation means. What does it mean to multiply this matrix by 5? What do you get? 30. 5x. And what? Negative 15. And what's the last one? 0. Okay. And there we are. Okay, we are almost there. So let's put together several things we did today. It looks more complicated, but I think you can handle it. When I look at this equation, what is this? What do you think I should do first? I'm going to look at the parentheses, and inside the parentheses, what should I do? Yeah, I should add those two matrices together. So this is a 2 by 2 and a 2 by 2. Let's add those together. So what happens when you add 2x minus 1? That's 2x minus 1. What is negative 3 plus 4? 1. What is 5 plus 3? 8. What is negative y plus 5? Negative y plus 5. So all of this is equal to 10 to 16, 14. Now what do you think I do? Yeah, multiply that on the left, everything by 2. What happens when you multiply 2 times 2x minus 1? Yeah, 4x minus 2, 2, 16, negative 2y plus 10. All of this equals 10, 2, 16, 14. This is where we started the lesson. These two matrices are equal to each other. What does that mean has to happen? They have to have the what? Same, start with a D, dimension, and every element has to be equal. I'm going to do the easy one for you. 2 is equal to 2, okay? What's the other easy one? 16 is equal to 16. Okay, we know that's true. What else has to happen for this to be true? Yeah. 2x minus 1 has to equal what? 2x minus 1 has to equal 10, right? And, oh, sorry, I back up. Don't let me make mistakes. Look, that's already my first mistake of the year and the first day. 4x minus 2 has to equal what? 10. And negative 2y plus 10 has to equal what? 14. Now, we've moved beyond arithmetic. This is algebra, but it's algebra what? What number? No, this is algebra 1. Solving for x, okay? Add 2 to both sides, okay? So this is 4x equal 12. What does x equal? 3.
Good afternoon, Upper School. We've got some announcements. That's our first day here. First of all, this is a message for all returning to Woodward students. New this year, all the police report to the office. John Glenn, police report to the office.
Okay, last problem here. I've got a matrix equation. So I've got a 3 by 1 matrix and a 3 by 1 matrix. So the only matrix I can add to a 3 by 1 and get a 3 by 1 matrix is going to be a 3 by 1 matrix. So a couple ways you can do that. You can just look at this and say that matrix A, if I've got a 3, what do I add to 3 to get 5? Well, that has to be a 2. What can I add to 7 and get a 2? That's a negative 5. What can I add to negative 2 and get negative 3? That is a negative 1. The other way to do this is algebraically. You know, if you had something like a, 5x, if you had something like 5 plus x equals 7, you would just subtract 5 from both sides. You get x equal 2. You isolate that variable. Same thing you can do with this equation here. You can say that A is equal to the matrix 5, 2, negative 3 minus the matrix 3, 7, negative 2. And then when you do this, you get A is equal to 5 minus 3, 2 minus 7, and negative 3 minus negative 2 is negative 1. So you get the same answer there either way.